Let's return now to our discussion of money demand. This time we will begin incorporating transaction costs in the model. But first, here's a puzzle for you to consider. A few years ago, Bank Central Credit had built a branch on the campus of TMAP down at the Student Center. How would you anticipate that this new branch might affect money demand, especially among TMAP students? Well, let's see. Intuitively, it is now more convenient than before to withdraw money from the bank. So you will leave money at the bank until you have to have it. Therefore, the new branch will reduce the demand for cash and more money. So this is an example of how a transaction cost of withdrawing cash may affect the demand for cash. Okay, so let's think about this a bit more formally with a model for cash in particular that depends on the interest rate, on the cost of going to the bank for one trip times the number of trips over a month. So, for example, if you go to the bank once a week, it may equal 4. And then in the parentheses, we have an expression for average money demand. The in this case, y is not income, but instead the amount of cash that you are withdrawing at the bank after one trip. So if you make only one trip to the bank, then your average money demand over the month is y over 2. This may be clearer on the whiteboard. Well, it would be if I could draw a straight line. On the horizontal axis, we will measure time. And on the vertical axis, we will measure the demand for cash, let us say over a month. So if you're making one trip to the bank per month, by the 30th day, you will be out of money. So cash demand goes to zero at that point. And then on the first day, you have withdrawn Y amount of money. So, for example, if you withdraw 100,000 tenge and you trip to the bank, Y is equal to 100,000. We will suppose that you spend the cash in a linear fashion over the month. So once you spend 1,000 tenge, you no longer are holding that money, and therefore your cash demand has gone down to 1,000 tenge. The average cash demand over the month is therefore y over 2. about their so that's the idea behind expressing average cash demand as a withdrawal divided by two. Okay, so far. Back into our model for cash demand. If you take the money out of your bank account, you can no longer earn interest on the money. So one cost of the cash withdrawal is the amount of interest payment foregone. We will express the interest rate as I in this case. So we want to take the number of trips to the bank and that will minimize the cost not only of interest payments foregone, but also the direct cost of going to the bank itself. So for example, if you have to spend 1,000 tenge in order to take a taxi to the bank, then your fixed cost of going to the bank is 1,000 tenge, and whatever the time cost may be in addition to that. All right so far. So notice that, for example, if you make 2 trips to the bank per month, then your average cash demand will be the withdrawal divided by 4 in this case. So if you were withdrawing 10,000 tenge, then you made only 1 trip to the bank per month, your average cash demand would have been the 5,000 tenge. But if you go to the bank twice per month, each time you're withdrawing $5,000, and then the average amount is 2,500 tenge. That's the basic idea behind including the number of trips to the bank in the denominator for the term that expresses cash demand on average. And there are the three variables that can affect the number of trips. James Tobin won the Nobel in part for this kind of work. Okay, so that's fine. The model makes sense, but how are we going to use it to express the amount of money that you truly will withdraw? So to find out, let's go to the whiteboard and model the problem. We want to minimize the interest lost on average cash demand, and also take into account the cost of going to the bank itself at penny per trip. And we want to solve the problem by finding the optimal number of trips to the bank. So let's take the derivative of d with respect to the n. And what are we going to get? So let's see. In the first term, we had n to the minus 1, and then I times y over 2 is a constant coefficient. So
Is it -2?
good close, minus I times a negative sign,
Y over n squared.
good, and then we have n to the power minus 2. So I will express it this way. And what else? Plus F.
Plus f.
Good. And all of this would be equal to what?
To 0.
Yeah, good. So that's our first order condition for minimizing total cost. So we have that F is equal to y over 2 times the inverse of the square of n. And then we have to solve this expression for n star. I will let you show that the optimum number of trips is the square root of I times y over 2f. For extra credit, in fact, this is one question that you can choose to answer on the midterm. Good, that's fine, but we really are not interested directly in the number of bank trips, but instead in optimal money demand. I will express that average cash demand is MD, and we already know that this is equal to the cash withdrawal divided by 2 times n now in star. So if you will plug in this expression for the number of trips and solve again, we have the money demand is directly affected by the initial cash withdrawal times the fixed cost divided by 2i, all of this expressed as a square root. So notice that this fits in well with our earlier discussion of money demand. It rises with the cash withdrawal, which also depends on income. And it relates indirectly to the interest rate, since a high interest rate will penalize us for taking cash out of the bank. And finally, as you have already pointed out, cash demand relates directly to the expense of going to the bank. Bank of Match, in this sense, have reduced F and therefore have reduced money demand in Kazakhstan. And there is the model. Questions, does it make sense so far?
I have a question. Where did you get the that equation?
Which one?
The y times f over 2I to the power of half,
Oh,
the
okay.
last one.
Let me write this out. So money demand in general is equal to the cash withdrawal of the average cash withdrawal. So we divide by 2 and then take into account the number of trips. So the more trips we are making, the lower the money demand per withdrawal. All right, so y over 2 is not a problem. And now we want to put in the denominator of money demand, then star in this case.
Oh, okay, I get it. You substituted.
Yes, that's right. But I have a typo put in star, so let me re-express it. Maybe this will help. This is Iy over 2f, and then taken up to the power of 0.5. So this is a square root expression for money.
Yeah, I get it. Thank you.
Okay. But other questions? This model expresses money as a kind of inventory. So where, for example, Van Store may be minimizing the total cost of its inventory of soup and food. This model will minimize the inventory cost of money. Okay, so we just worked through the optimization problem, but here's an interesting question to consider. What sign should the second derivative of n of g with respect to n have? Now that we are minimizing money demand, or I should say we are minimizing the cost of withdrawing and holding money. Now let's see. Back to the whiteboard for a minute. With a general graph of some cost function that we wish to minimize. So I'm just going to refer to x, and then on the vertical axis, express the cost of x. And here is a convex function that we minimize about right here. There is x star. So of course, the first derivative of cost with respect to x is zero at x star. But to pick a point that minimizes cost rather than maximize it, we've got to characterize the second derivative, that is the derivative of the first derivative. Well, clearly, the derivative or the slope is negative in the beginning, and then as x increases, it is leveling off, becomes less negative, and then actually turns positive over here. So the second derivative is positive or negative in this case. What would you expect? Let me draw marginal cost over here. With respect to x. So marginal cost in this case is equal to the first derivative of cost with respect to x. It looks like this. And we have that marginal cost is increasing, maybe negative in the beginning, but eventually turns positive this over here. So that would draw this very roughly. Looks something like that. Now, we wrote the derivative of this marginal cost. What is the sign of the derivative? Is it positive or negative? And clearly, marginal cost with respect to x is a function with a positive slope. That slope is the second derivative of cost with respect to x. So to minimize cost, we require a derivative, a second derivative that is positive. There is our sufficiency condition. To identify a point that minimizes cost in this case. We want a second derivative that is positive. You remember that when we were maximizing utility, we had assumed a negative second derivative for a maximum problem. So it makes sense that if we have a minimization problem, people want a second derivative with the opposite sign, positive rather than negative. So one question that you can try for extra credit is to determine whether the second derivative with respect to n is positive in this function. Due next Wednesday for extra credit. Okay, so we have discussed money supply and money demand. Today, we extended the money demand function, the model, to take transaction costs into account. And there is the two sides put together in the same graph, money demand and supply. So, for example, what changes do we have when we take an increase in income into account? For example, higher income in Kazakhstan because of a rise in demand for oil around the world. What happens now if income rises? Well, let's see. Here is the money market. But the nominal interest rate, the market interest rate on the vertical axis, and many on the horizontal. You remember that we will assume in Kazakhstan that the National Bank has to take the interest rate as given by global financial markets. So money supply is independent of the interest rate. The central bank can determine in the long run the number of piggy in circulation, but it cannot determine the interest rate. And there is money demand. That reduces at higher and higher interest rates. Why? Because he moved. If you can earn a high interest rate by buying securities, then you will want to go right ahead and spend your cash on those securities. By spending cash, you're reducing the demand to hold cash. So we have an inverse interest rate relationship with money demand. Okay, now income rises. What happens now to money demand? At any given interest rate, we demand more money than before because with higher income, we can spend more to tomorrow And to prepare for that spending, he must withdraw more money, more cash today from the bank. So there's a positive relationship between money demand and income. So here's money demand at high income. Like that. So what happens to the interest rate as income is rising? Well, let's see. Um, in the beginning, if the interest rate is fixed, then money demand will exceed money supply. So even though the national bank cannot affect the interest rate in the long run, the excess money supply in the short run will cause the interest rate to rise. In order to reduce money demand to the level of money supply that has been mandated by the national bank. So let me note that over here. In the long run, such a fund must take as given the global interest rate. But in the short run, we may have in Kazakhstan temporary changes in the interest rate. For example, if we have excess money demand, as we have right here, then the interest rate in Kazakhstan must rise to eliminate the excess demand. So you move from A to B and over to C, eventually to restore equilibrium in the money market. So there is a, one solution to the problem, a short run problem. And there is a summary for the discussion. Although money demand also depends on the interest rate and transaction costs, it appears that money demand depends mainly on the amount of spending money that we want to have in our wallets. And there is an extra further problem that I will leave to you to finish answering. Okay, here is another way of expressing our money demand model that may help you on the midterm. We said that money demand ultimately is the square root of the initial cash withdrawal Y times the fixed cost of putting to the bank divided by the interest rate times 2. All of this at 0.5. But this is a rather cumbersome model to be using. It is non-linear. So to profitably express this model, not directly, but in terms instead of the natural log. So let's see what we have. We have the square root of y. So this is 0.5 times the natural log of y. And what's next? F is also expressed as a square root. So there is another term in the natural log expression. Minus the natural log of 2, a constant, and then what remains? The interest rate, which is taken to the power of minus 0.5. So there is a remaining expression.
So shouldn't the 2 be to the power of a half as well?
Oh, that's the log. Yes, thank you. Good, thank you. So if you've taken econometrics, you may already be acquainted with the double log function. You can run this expression in Kazakhstan, a constant which in this case is 0.5 times the natural log of 2, and then b times the natural log of y, another coefficient c times the natural log of the fixed cost of bringing to the bank. And then finally, minus d times the natural log of the interest rate. Okay, so if the inventory model is correct, what sign do you predict for B? What does D equal from the model over here? So we anticipate that D is equal to 0.5. We can test that, that prediction. C is also 0.5. And then D, if we express D as either positive or negative, what are we predicting if the inventory model is correct? Minus 0.5. So there are three hypotheses for the inventory model. And of course, we could extend this to the intercept A that we predict is equal to minus 0.5 times the natural log of 2. On the midterm, I give you an incomplementary model for Kazakhstan that tests the inventory model. So you can see for yourself whether the model makes sense for us. Let's move on now to talk a bit about unemployment. Unemployment is one of our three main issues in macroeconomics. We've already talked about the business cycle and money supply and demand. In particular, I hope that you will bring away from this discussion an idea of how to model the long-run rate of unemployment in Kazakhstan. The classical labor model we will return to next week. So in your readings, I hope that you have a chance to take a look at chapter 6. And maybe, if you have time, chapter 2 of Keynes's general theory. Another recommended reading that is on the Moodle page. And some problems for extra credit. Okay, here is the real world. Unemployment in Pakistan typically has fallen throughout the country. This is true of the nature of the financial crisis in 2009. So you can see that there was a slight increase in unemployment during the crisis, but then it began falling once again. In particular, the unemployment rate among young people has been dropping very sharply in Kazakhstan in recent years from the housing boom of 2007 through the end of the financial crisis in 2010 continued to fall. However, unemployment was high during the crisis in Almaty, higher in fact than in most of the Oblast, and for the nation in general. So that's rather interesting. Any ideas about what might be accounting for that high unemployment rate in Almaty?
Um, high high population.
Say again, I did not quite hear you.
Is it high population?
Well,
Higher population and not less. Not that much of companies that would accept young people. I don't know.
oh, no, that's a good question. This is the unemployment rate for all age groups on average in Kazakhstan, in Almaty in particular. You would think that a large population, especially in a city that is rather dense, would attract firms. For example, a restaurant in Almaty, the restaurant would have a larger potential market than in South Kazakhstan, the rural area. So most guess would be that population density is more likely to be associated with a low unemployment rate than a high one because the density is attracting firms, both that sell to the local population and those that want to have a large labor force to choose from. From that point of view, we might anticipate a low rate of unemployment in Almaty, and yet that seems not to have been the case in 2009. One other possibility may be that the financial sector plays a dominant role in Almaty's economy. The banks in 2009 crashed and therefore had to cut back on employment. So this may be expressing the direct impact of the financial crisis on Almaty's financial economy. And there is the ratio of unemployment in the cities, Almaty and Nur-Sultan, relative to the national unemployment rate. So you can see that the ratio is above 1 for the cities, even as recent as 2010 after the crisis. That is to say, unemployment in these years was higher in the cities than in the nation. So there are three questions that we can ask about unemployment in Kazakhstan. Now, let's take a look at the model that may help us to answer those questions. All right, as you know, the labor force is comprises the employed and the unemployed in Kazakhstan. We are defining unemployment as the number of people who are looking for work but not able to find it. So, from this point of view, a student in college and undergraduate is not unemployed even though he is not working because he is not looking for work. He is concentrating on his studies instead. The student is outside of the labor force. And if you have a relative who has given up looking for work, that relative is technically not unemployed either, because you are unemployed only if you are still looking for work. Instead, he is regarded as a discouraged worker. Okay, just two more variables to consider. S is the rate of layoff or firings, the rate at which the firm is getting rid of separating away from employees. And then F is the rate at which the unemployed finally find work. So we have an equilibrium if the number of unemployed who find jobs just equals the number of the employed who lose their jobs. So there is a steady state in the sense that the demand for jobs is equal to the supply. Here on the left-hand side is the number of the unemployed who are finding jobs. Then here is the number of employees who are losing their jobs. We can express employees as the share of the labor force after we have taken out the unemployed. So remember that the labor force is equal to E plus U, the employed plus the unemployed. And then for extra credit, or for a question on the midterm, I will let you manipulate this expression to show that the steady state rate of unemployment reflects both the job finding rate and also the rate of separation. Okay, over so far. So here's a question that you may find intriguing to try. What is the job separation rate for graduates of TMAP? In the first jobs? But for right now, let's apply this model to a couple of issues in the news. So, for example, during the lockdowns of the summer, firms were laying off more workers than before. How would that affect the steady state rate of unemployment? Well, let's see. If S increases, what happens to the ratio of U to L? A higher separation rate is reducing this ratio of F to S, thus reducing the denominator and raising the rate of unemployment as a consequence. Now, on the other hand, the internet has introduced websites that make it much easier to find a job. So, in the age of the internet, we have a rise in F, the job finding rate. How will that affect the equilibrium rate of unemployment around the world? Now, the increase in F is increasing the denominator and therefore lowering the ratio, the fraction. That means that the unemployment rate will fall as a consequence. Okay, so let's come back to our TNET problem of the unemployment rate among our graduates is very, very low, no higher than 3%. And then our graduates, on average, can identify 6 job offers in the year after graduation. So, what is the job separation rate among our graduates? You can answer that question by substituting 3% for the unemployment rate and then 6 for the job finding rate. 2 extra credit. Okay, I'm running out of time, so let me pause now for your questions. about the intuitive model of money or about the steady state rate of unemployment.